Okay, good morning, everyone. Hope you all had a good weekend. We are going to be covering partial fraction decomposition, continuing what we did last week. And we should get through this today, and then that'll set us up for circles on Wednesday. Just remember that the homework assignment for this section 12.5 will be due tomorrow at about midnight, 11:59 p.m. So when I finish up the lecture today, I'll open up the assignment and we'll just kind of take a look at it, and just so you have an idea of how many problems there are if you haven't already looked at it, and just so you have some sort of notion of how much time it's going to take. All right. Okay, so today let's continue where we were. The last problem that we had done was, let's see here. We had done this one here, where we had, when we factored the denominator, we had repeated linear factors. And so we saw that we had to do something kind of odd here. And we actually did not finish this problem. So we do need to wrap this one up. So hopefully you can recall what we were doing here. We had factored, we saw that we had x minus 1 twice. So it was repeated. So we wrote a over x. That covered this first linear factor. And then when we had the repeated one here, we had to write x minus 1 and then x minus 1 squared. And then we multiply both sides by the common denominator. And here's where we were. We were trying to use that short method where we kind of kill things off. And we realized that it might be tough for us to figure out what, well, we were trying for B and C, and I think we ran out of time. So are there any questions before I start, or continue, I should say, with this problem? We're good? Okay, so let's go for trying, let's see, if we try to figure out what B is, okay, if we're going to try and focus our attention on B, then we have to be able to kill off the A and the C at the same time. But we saw that there's no way we could do that. If we let x be, let's say 0, it would kill this off, right? But then it also kills off the B that we're looking for. Does everyone understand that? Yes?
Yes.
Okay. And if we try and kill off the A, we have to let x be 1, but then that also kills off this factor becomes 0 also, so it kills off the B, so it doesn't work. So what we're going to do is we're just going to wait on B. We're going to go see if we can try and find C. All right, so let's see if we can find C. So to find C, we can actually choose something here that will kill both of these off without killing off this one, right? So if we let x be 1, it should create zeros here, and it should keep this one here. So let me do that. Let's let x be 1. And then if we let x be 1, let's rewrite everything. So just remember, you have to replace the x here with 1. So you get 1 plus 2 equals, now we know that we're going to get a 0 here. So that's going to kill that off, 0. We know that we'll get a 0 here, so that'll kill the middle one off. And then if we replace the x here with 1, we'll just get C. So solving this, we get C is 3. So we have 2 of the 3 things we're looking for, but we still have to figure out what B is. All right. So there is a way that we can do this. But do you remember, I told you there was a short way and a long way, right? And my thing is, whenever the short way isn't going to work to get me all, every letter I'm looking for, A, B, C, whatever, it's not going to work. I always defer to the long way. That's just my personal thing. There is a way we could manipulate this. Like right now, we could go in here, we could replace this A with 2. We could replace this C with 3, and then we could try and multiply everything out and see if we could get B. But again, anytime I can't get them all with the short way easily, I just go to the long way. That's just what I do. So I think it's important for you to understand that I personally don't think it's worth your time to go through what I just did. If you see immediately you can't get them all, just go to the long way. All right. So what I'm going to do is let me clean this up a little bit. I'm just going to copy this here. I'm going to take it to a new page. I'll go over here. And we're going to do the long way. So the long way requires that we multiply everything out. So you have to be careful here because you do have to square this, right? That means you have to do x minus 1 times x minus 1 and then FOIL that out. So I'm not going to show the work there. I trust that everyone here could get this. If you multiply those two together, you should get x squared minus 2x plus 1. And so that will be sitting here with an a in front of it. And that a will have to distribute, but I'll do that on the next step. And then on the second one, we do need to distribute. I'm going to distribute both the b and the x through here and here. So if I do that, I'm going to get a bx squared and then minus bx. And then the last term, we just have c times x. All right, next step. Let's go ahead and pass the a through. And I always like to write my number first, then the letter I'm looking for, and then the x. So that's why I wrote minus 2ax there, and the second distribution, plus a. Are there any questions while I write this out? Are there any questions?
No, sir.
Okay, thank you. All right, so now once we've gotten to this point, can somebody tell me what I would do next?
You would collect like terms.
Collect like terms, right? So we're going to collect our like terms together. So I'm going to, let's look at all the x squareds. I have an ax squared there. I have a bx squared there. So I'm going to try and move a little faster, okay, than I did last time. Let's see if this makes sense. What I'm going to write here is a plus b and then x squared. So what I've done there is I've put the ax squared plus bx squared next to each other and factored the x squared out, but I factored the x squared out of the back side instead of the front side. So any questions on that?
And that will help us find the missing term c, right? Because we're combining those together.
It's going to help us figure out what a, b, and c are. We're going to wind up setting up a system of equations. That's what this is all going to turn out to be.
Oh, okay. Thank you.
Okay, now I'm going to look at my x terms. This has an x in it, this has an x, and this has an x. So maybe I'll just off to the side show you what I'm really doing here. I'm putting minus 2ax together with minus bx together with plus cx. And since they all have an x, I'm factoring the x out. So I'm pulling the x out, which leaves me with a negative 2a minus b plus c. But instead of putting the x in the front, I'm going to put it on the back. Okay, that's what I'm doing here. So I'm going to put plus in parentheses negative 2a minus b plus c, and then here's the x. And then the last thing to do is to write down whatever doesn't have an x in it. And the only thing that does not have an x here is an a. So I'm just going to put plus a.
I have a question.
Yes.
So for the negative 2ax minus bx plus cx,
Yes.
couldn't you also just put the minus sign in front of the x outside of the parentheses?
Good question. So could you make this a minus and then make that 2a plus b minus c, maybe something like that?
Yeah, and in terms of solving the problem, would that make it any more difficult?
I actually think that might create a tricky thing for you. Okay. Because here's what we're going to do. What we're about to do is look at the left side of the equation and try and match these coefficients, these things, to what's happening on the left. And if you factor a negative out of this one, then you're going to be matching, but you're going to be off by a sign. You're going to have to realize that. Let me go through this, and I think it might become clear once I do it. Okay, so first thing I'm doing is I'm looking at the left side and I'm realizing that there's not an x squared, right? On the right side, we have an x squared and we have a plus b in front of it. But on the left side, we don't have an x squared. Well, we actually do. We have a 0x squared. So you have to realize that there's a 0x squared over here. And then you're going to match the coefficient. You're going to say, okay, whatever number's in front of x squared here has to match with what's here, right? In order for this equation to be true, that would have to be true. We would have to have that a plus b would have to be equal to 0. Now I left a space here because we have c's in here also. And when I set up my system of equations, I'm going to leave myself a position for c. Okay, so Maddie, this is where I think things might be a little bit tricky. So if you look at the left side, we have a plus 1, right? A plus 1 in front of x. And that plus 1 or positive 1 needs to match up with whatever's in front of here. If you had pulled a negative out here, then it would, do you see that it would be, you'd be looking for the opposite, and that would be, I think it would create a confusing scenario for you. So here I can just write, all right, negative 2a minus b plus c, that must equal whatever's in front over here, which is 1. Is that clear to everyone?
Yes, sir.
Okay. And then the last thing is whatever number is by itself, so positive 2 must match anything over here that doesn't have x, so it must be matched up with a. So I can just write my last equation, a is equal to, what, 2? And there I have a system of equations. And so for this system of equations, I mean, in college algebra, you learn how to solve systems of equations, but this we could actually do if we just kind of take our time through it. We already know that a is 2, right? We know that because of the last equation. Agreed? Now, if we look at the first equation, a plus b has to be 0. But if we know that a is 2, then this becomes 2 plus b has to be 0. And if we subtract 2 on both sides, we'll get b is negative 2. Understand?
Yes.
And if we look at the second equation, right, this one, we know that negative 2a minus b plus c must be 1. And so we know a is 2, right? So this becomes negative 2 times 2. We know b is negative 2. Be careful here. So minus negative 2 plus c must be 1. So that's just me plugging in the a and the b into that second equation. This becomes negative 4 plus 2 plus c equals 1. So that becomes negative 2 plus c equals 1. And if we add 2 to both sides, we get c is 3. So now we know what a, b, and c are, right?
Yes, sir.
And if we, yeah, go ahead.
So if we, so basically as we find one of the 3, we can use that one and plug it in to find the other 2.
Not all the time, but in this problem, yes. Like if all of these equations had an a, b, and c in them, then you would have to use elimination, which would take quite a bit of time. And so we kind of got lucky here. And most of the problems that you do here, you're going to be able to do this, but I can't say that in general it's always going to work this way, just generally speaking. In fact, in Cal 2, I teach my students how to use their calculators to solve systems of equations. And when we get to this step, we just go to our calculator to do it. That's what we do. So, all right. Okay, so does this match what we had when we started trying to do it the short way? We had that a was 2 and c was 3, but we didn't know what b was. And now we just figured out that a is 2, c is 3, so that's good. It's the same, right? And then now we know what b is. B is negative 2. All right, so what's the final result? Okay, we go back here, and let me just go ahead and grab this. Yeah, I better just grab that. I'm gonna erase some of this stuff. So the whole idea here was that we were trying to rewrite this up here. You know what, I'll do it right here. So what we said is that this must be this right here, right? But we figured out that A had to be 2, right? Correct me if I'm wrong. I think A was 2. So this is 2 over X. Plus, let's see, B was -2, right? -2
Yes.
over X minus 1. And then plus C, which is 3 over X minus 1 squared. There we go. And what we've done there is we have done the partial fraction decomposition of that rational expression. And like I said last class, we need to be able to do this in Cal 2 in order to continue with a bigger problem that we're doing in Cal 2. So this is usually the first step for a larger problem later. Okay, any questions? We're going to get more practice today, so don't worry if you're still freaking out a little bit. All right, so here's the new one. We have instructions here to find the partial fraction decomposition of this. So I put the steps here. And first step is to inspect the degree of the numerator and denominator and compare them. So when you look at this, the degree of the numerator is 3, right? What is the degree of the denominator? Does anyone know what its degree is?
5.
Is it
5.
5?
Yeah.
Be 5.
Mm-hmm.
And that's because we have an x squared. But then this x minus 1 cubed, if you were to multiply this all out, x minus 1 times x minus 1 times x minus 1, the highest power of x you would have there is x cubed. And then you would have to hit it with the x squared, so it'd become x to the 5th. So even though it doesn't look like there's an x to the 5th, you have to understand that there is. And that means the degree of our numerator is less than the denominator. And so we're just going to move on to the next step. So the next step is to factor the denominator completely. And can somebody tell me what the good news here is?
What happens if the numerator and denominator have equal degrees?
If they're equal, that would be case B here.
Okay,
And we
that's what I
haven't
thought. I just
done
wanted to
anything.
make sure.
Yeah. So if the numerator has to be smaller than denominator for us to move on. If it's equal, or if the numerator degree is bigger, then we have to do something else, which I've carefully avoided that up to this point. We will do something with that in a little while. Okay, it'll add another step we have to do. Okay, so we are at step 2, factor. So what's good about this? What's good about this problem?
It's already factored.
It's already factored, right? It was presented to us that way. Was there a question there?
Yes, sir. So on this one, since we don't have, we would just be trying to find x, right? Since there's no other letters like our last problem.
No, we have to. This is where we have to put in those letters.
Oh,
this is the point. Okay, so we have to now look at our denominator, which is factored. Okay, it's factored because it's already got, parentheses. Things are pulled apart. Things are squared and cubed. So let's look at our first factor. And this is a little tricky. This x, just the x by itself, is linear. But the fact that it's squared means it's repeated. So if you recall from last class, what we did is we said, okay, anytime we have a repeated linear factor, what we're going to do is we're going to put a on top of the linear factor, and then plus b over that linear factor squared. And we keep doing that. We keep building up the powers on that linear factor until we get to the number that matches this number. In other words, we're done at this point with this x factor. Then we move on to the next factor, which is x minus 1. That is linear, but it's cubed. So that means I'm going to have to do plus, someone tell me, c over what?
X minus 1.
Okay, c over x minus 1, and then plus
D
over
X minus 1
x minus 1
squared.
squared. And then I need another one. E over x minus 1
cubed.
cubed. And that's where I stop. I stop there because there's a cubed here. So it's like you're building up, you keep building these up until you get to the power, the highest power, and then that's when you can stop. Okay, can you already tell this is gonna suck? I mean, this is gonna be a lot of work here. Okay. All right, so, but this is it. I mean, this is the way it is. So now we multiply by the LCD. So I'm gonna multiply both sides by x squared, x minus 1 cubed. And then this whole side gets hit with x squared times x minus 1 cubed. All right, so obviously we don't want to be, we want to try and save ourselves time. So we want to do as much of this like mentally as we can. When we take this entire factor, we have to distribute it through. We have to hit every single one of these with it, right? Every one of those. All 5 get hit. So I think it's time for me to call on somebody here. Let's see, Michael. Is Michael here? Michael Myers.
Yeah, I'm here.
How's it going, Michael?
I'm good.
Okay. So when I do the first distribution, let's say this thing out here to this one here, what is left? What's still there when I multiply through?
Just say.
Okay, A's there. Okay, that X went away, right?
Yeah.
We canceled with one of those. But so that means there's still stuff here. What's still here next to the A?
It would be the x parentheses x minus 1.
Yep, an X and an X minus 1 cubed, right? So that's what happens when we go here to here. Everyone clear on that? And then we just continue this. When I do the second one, what cancels is the x squared with this x squared. So that's going to leave me with the b. And then all I have left is the x minus 1 cubed. And then the next one, let's see, just the x minus, just one factor of x minus 1 cancels from here. So that means I'm going to have the c, I'm going to have the x squared, and I'm going to have an x minus 1 squared. When I do this one, let's see, I have an x minus 1 squared cancels, so I still have the x squared. I still have one factor of x minus 1. And then when I do the last one, the x minus 1 cubed cancels, but I still have the x squared. Oh man. Okay, and now on the left side, those cancel, so all I have is x cubed minus 8. And so I've got some pretty bad news at this point, because you can sit here and try and get A and figure out short way, but it's not going to work. There's too many factors that appear in all the other ones. You'll see that. I mean, it's just like you might be able to get, let's see, we could get B. If we let X be 1, I'm sorry, X be 0, we could get B because it would kill off this one and this one and this one and that one. So we could get B. But other than B, let's see, we get E, but that's it. We could just get B and E. That's it. Just B and E.
I actually have a question really fast.
Yeah.
For B, how come we don't put the X after B like we did on A?
Okay, so let me just do it. We did this. We're doing this times this, right? For that one?
Yeah.
So if I do B over X squared, and I multiply that times X squared times X.
Oh, okay, yeah. I see.
Got
I see. Yeah, thank you.
Yep, good. Yeah, please ask those questions, because if you don't see that, then of course it's going to be confusing, right? All right, so if I think we're going to abandon the short way. You know, it is what it is, which means we have to expand the right side out. Everything's got to be expanded out. Wish I had better news for you. That's the way it's going to be. So let's do a couple of things. We are going to need to know what x minus 1 cubed is, right? We're going to need to know that. We're going to need to know it there and there. We're also going to need to know what x minus 1 squared is. So let's just take a moment to figure out what those two are. So let's do x minus 1 squared first. We already know that if we do that,
Should be x squared minus 2x plus 1.
Minus 2x plus 1, right? So that's if you FOIL and collect like terms. Now, x minus 1 cubed, does anyone know what that is without doing it by hand? There's actually like a shortcut way of doing it, but I'm not going to get into it at this point. But so what you do here, okay, if you don't know the shortcut way, is the way I like to do it is I like to put two of these together. So I like to put these two together, and that's this. We already know that from up here. And then at this point, I like to distribute my x through, and then after do that, I multiply my -1 through. So when I pass the x through, I get x cubed minus 2x squared plus x. And then when I pass the -1 through, I get minus x squared plus 2x minus 1. And if you collect all your like terms together, you get x cubed minus 3x squared plus 3x minus 1. So maybe that would take you a little bit of time, but you know, I do hope that everyone would be comfortable doing that. All right, here we go. This is not going to be fun. Okay, x cubed minus 8 equals. Okay, so this right here in purple that I've circled here is actually all of this, right? But I've got to hit it with an ax. I'm going to try and do this all in one step so I don't have to write so much. So imagine hitting all of these with an a times x. I should get an ax to the 4th minus 3ax cubed plus 3ax minus, ax squared minus ax. Do you all agree that that's what would happen if I take this in orange and hit it with an a times x?
Yes.
Okay.
Yes.
Now, the next one is this x minus 1 cubed again, but I need to hit it with a b. So I'm going to take this again. I'm going to hit every one of those with a b. So plus bx cubed minus 3bx squared plus 3bx minus b. I think it's safe to say that there's a lot of room for error here, right? I mean, it would be very easy to make a mistake.
Oh yeah, just by 1 power could mess
Oh yeah,
up.
you miss one thing and it's over, right? So that's what makes this so challenging. You have to be very, very meticulous, and you have to be precise with everything. All right, I need to continue. So now I'm on to the next one. I have x minus 1 squared, which we said was this. And I've got to hit that with a cx squared. So here we go. I'm going to hit this first one here with the cx squared. So that'll become cx to the 4th. Then I hit minus 2x with cx squared, so minus 2cx cubed. Then I hit the 1 with the cx squared, so I get plus cx squared. If you're finding that you're running out of room, that's just kind of the nature of this. I'm probably going to run out of room here. Okay, next one, where are we? We're here now, right? I can just pass the dx squared through this parenthesis. So I hit dx squared, hit x with it, so I get plus dx cubed. And then I go dx squared times -1, which is minus dx squared. And then finally, the last thing out here, ex squared, I don't have to do anything with. All right, I'm going to erase this stuff on the side here just to get it out of my way. Hope that's okay with you. There it is. Now we have to collect like terms. So I'm going to start by looking for the highest power of x. So here's the highest power of x. I have ax to the 4th. So that's the only one I have. So I'm going to go ahead and write this x cubed minus 8 equals.
Real quick, I have a question.
Yep, go ahead.
Okay, so when you multiply like cx squared by x cubed, wouldn't that be cx to the 5th power?
Yeah, did I miss one there or something?
You had cx to the 4th power, and I was just confused because when we multiplied ax.
Oh yeah, I should have a 5th power here. Hold on. Let me back up. Okay, so which one would that be? Cx squared? Oh, well, wait a minute. No,
That
maybe
should be
not.
a 4th power.
I'm just asking.
Oh yeah, yeah.
Yeah.
If you hit an x cubed with an x squared, it'd be x to the 5th. Is that what you're asking?
Yes.
Yeah, yeah.
Okay, because we wrote it down as x to the cx to the fourth and then to the third and
Right,
then to the
right here,
yes.
this one, okay, but see, I was doing the CX squared times X minus 1 squared. X minus 1 squared is this one, right? So when I hit this with CX squared, it becomes CX to the fourth.
Okay, I see. I thought we were multiplying it by something else. My bad.
Had we been doing this one, then that would be a CX to the fifth.
Okay, I see.
You sure?
Yes, thank you.
It's Monday, so it's very likely that I can make a mistake here today. And I'm also human, so you know that also factors in. We're all human, right? That's why it's important on your exams for you to show me your work, because if I can see where you make a mistake, I'm not going to take off as much as if you just like don't do much work. You know, so if I can go and look, oh yeah, you accidentally did C, you know, X to the fifth there or something. And I'm not going to take off as many points as I would take off if you just like had a bunch of gibberish stuff that didn't make sense. So partial credit will be given in this class, but you have to show me work so that I can see where things went wrong. Okay, so here's my X to the fourth. So I've taken care of this. Let's go look at our X cubes.
Professor,
Yes?
don't we have 2x to the 4?
Is there another fourth? Oh, there's another fourth. Thank you.
Mhm.
There we go. It's right here. I didn't see that one. Plus CX to the fourth. Yeah, we were just talking about that one. Okay. Now we've got the X to the fourths taken care of. Our X cubes. I would have figured it out eventually because what I do is when I do this, I usually cancel them once I've put them together. So everything in yellow has an X cubed in it. So I'm going to put, let's see here. I always put a plus, and then in parentheses, let me put the coefficients. I have a negative 3a plus b minus 2c plus d, and then I put the x squared out back. So that's me putting all the yellow ones together and pulling the x squared out the back side. Is that all right?
Are we gonna pull the x to the fourth out too, or just leave it as is?
Why'd I do x squared, x cubed? Sorry. I'm sorry, say your question again. Oh
Are we-
yeah, we'll do that. We'll do that one on the next line. We'll do that
Okay.
on the next line. Because I forgot it, I hadn't pulled it out. So let me cancel these out. Okay, so I'm done with those. And I know that you don't have colors, okay, like most of the time when you're writing. So you might do this instead. Like when I do the x squareds, I'll circle them. And let me make sure I get all of them here. All right, so I'm circling those, and now I'm going to put those together. I always do a plus parenthesis, let's see, a 3a. That takes care of that one. All right, I have a minus 3b. That takes care of that one. I have a plus c, that takes care of that one, and a minus d. And then I have an x squared that I pulled out there. And now I'm going to move on to the x's. And so instead of circling, I'm going to put boxes around the x's. So x there, that one has an x. And that's it. These are the only two with x's, right?
No, there's an ex squared as well.
Did I accidentally erase the x squared off the back of this?
I think so.
I think I did. Someone look back. I think when I erased all this stuff, I may have erased the x squared off of that.
On the equation up above it, there's the ex squared.
Yeah, I know, but guess when I copied it down? And y'all, I need y'all, thank y'all for being sharp today, because obviously I'm not. So what am I missing here?
Just the e, I think.
The x squared, yeah. So e and then x squared. My apologies. All right, now we can cancel it. All right, I need to get together here, Robert. All right, so now the x's. All right, so negative ax. So that's a negative a, and then plus 3b here. And that's it for the x's. So I'll put an x there. And what am I looking for now? Anything that doesn't have X, right? And I can see here that I have something. And again, if I only have one color, I could do something different. So I'll do like a squiggly circle around that or something. So that way I'm kind of making sure I cover everything. So just minus B out here. Just enough room. And that covers, I think that took care of everything there. Now I am going to go back just to save ourselves some time. I'm going to go back and I'm going to just clean this up out here. I'm just going to make this the A plus C and factor the X to the fourth out. That way we don't have to rewrite it all. All right, now it's time to match coefficients. So we look on the left side, we look on the right side, we try and match. So on the left side, do we have an X to the fourth on the left side? We do not, right? We don't. That means that the A plus C has to be equal to what?
0.
0, because we're really looking at this as being like a 0x to the fourth out here. So anytime that variable doesn't appear on the left side, you'll just set those to 0. So A plus C must be 0. Now look at the way I wrote that. You see how I wrote that? A plus, I left a space, C equals 0. The reason I did that is because I know I have A, B, C, D, and E in this. So I'm just kind of giving myself room for all those variables. All right, that takes care of that. What about this one? Minus 3A plus B minus 2C plus D, all that. How about Samuel? Is Samuel here?
Yes.
Okay, Samuel, are you following this?
Yes.
Okay, so can you tell me what all this negative 3A plus B minus 2C plus D has to be equal to? You're trying to match it up with what's on the left side. So you're looking at what is in front of X cubed. So what's in front of X cubed on the left side, Samuel?
Minus 3A. I mean, on the left side?
On the
the equal
left
sign?
side, on the left side, what's in front of X cubed?
Oh, minus 8.
No, what's in front of it? What's the coefficient of this? What's the number sitting here we don't write?
1.
1, right? There's a 1 in front of that. And so what we're saying is whatever number's in front of X cubed here has to be equal to the number that's in front of the X cubed here. Does that make sense, Samuel?
Yes.
Okay, so we set it equal to 1. Okay, let me see. Next piece is all of this. Let me write that down. That has to match up with something over here. We'll talk about that in a second. Let me write it down first. 3A minus 3B plus C minus D plus E. Cameron,
Yes, sir.
what does that have to be equal to?
Well, since there isn't a x squared, would it just be 0?
That's right. Since there is not an X squared, it'll be equal to 0. Perfect. Okay, and then the next piece is this stuff in front of X, which has to, I know this is starting to look like a spaghetti factory over here, but negative A plus 3B has to be equal to, let's see, Joshua, what does that have to be equal to?
That'd have to be equal to, it'd be like 0 times, it'd be 0 times X, so 0.
Yeah. So 0 again, right? Because there is no X over there. And the last one, Maddie, what does negative B have to be equal to?
Negative B has to be equal to negative 8.
Negative B has to be equal to negative 8. So the thing over here on the right that doesn't have X on it has to match the thing over here that doesn't have X. So we know that negative B has to be equal to negative 8. All right, here it is. We have a system of equations. We have 5 equations and we have 5 unknowns. So even in college algebra, most of the time you're limited to either 2 equations with 2 unknowns or 3 equations with 3 unknowns. Now we're looking at 5 equations, 5 unknowns. However, we might be able to figure things out here. Do we know anything right off the bat? Anyone? Do we know what A, B, C, D, or E is?
You
B
can
equals
Okay,
8.
B is 8, right? Since negative B equals negative 8, we know B is 8. And I'm going to number these equations. This is equation, let's say 1, 2, 3, 4, and 5. So equation 5 tells us that B must be 8. Okay, Sierra, you there?
Yes.
Okay, Sierra, what equation can I use now to get another letter? Remember, we know what B is, right?
Right.
So which equation can we use that?
I would
information?
say the fourth one.
The fourth one, yeah. The fourth equation tells us that negative A plus 3 times B, but don't we know B is 8?
Yeah.
Okay, so 3 times 8 must be 0. And 3 times 8, I believe, is 24.
Mhm.
And now you can either move the A to the other side or subtract 24 and then divide by -1, but we should all be able to get that A is 24. Y'all agree? Okay, so we know what A and B are, right? We know what A and B are, right? So let's see. Brianna, are you around?
hello.
Hi, are you following?
Yeah.
Okay, so we know A and B. What would you like to go do now?
I would do number 1.
Okay, so you're going to go get C. All right, so
Yeah.
using equation 1, we know that A was 24, right? So plus C has to be 0. So Brianna, what's C?
Negative 24.
Negative 24. Okay. So now we know A, B, and C. Karen, you're up.
Okay, so
Which equation do you want to mess with? We know A, B, and C.
2.
2, right? Now we would not want to do equation 3. The reason we don't want equation 3 is because if we know A, B, and C, equation 3 still has 2 things we don't know, D and E. So we use equation 2 because it has A, B, C, and just D. Yeah, all right, so here we go. Equation 2 tells us that -3 times A, which is 24, plus B, which is 8, minus 2 times C, which is -24, plus D must equal, be careful here, 1, right? So that's me just taking equation 2 and plugging A, B, C in. And let's see if I can do some basic math now. -72 plus 8 plus 48 plus D equals 1. All right, what's that? Negative. My brain literally shuts down when it comes to arithmetic. I just don't care. -64 plus 48 plus D equals 1. I think I'm getting that right. What do we got here?
Negative 16.
Negative 16, and then add 16 to both sides. So D is 17. We are almost there. No worries, we're only 45 minutes in the class. You know, we've only used 45 minutes of class to do this problem so far. Well, no, we did a problem in the beginning. It's been about more like 35.
Sir, I have a quick question.
Yeah.
Is this the longest problem you've done, or like have you done a longer one in the
Oh
past?
no, I've done longer than this.
Really?
But yeah, but you in Cal 2, you get some that are like 6 or 7 equations, 7 unknowns. Yeah. But that's why I teach them to use their calculator. So like at this point right here, we would stop and just go to our calculators.
Calculator. Oh, okay. I thought you did all this like with 7.
Yeah, nope. And we're getting lucky because we're able to do it. Like we could use equation 5 to get B, and then 4 to get A, and then 1 to get C. So it's working out great for us. And the problems that you're going to get on your homework will be like you'll be able to get them. Like again, if all of these had A, B, C, D, and E in all of them, you would not be able to do it. Like you would be stuck unless you really understood elimination. from college algebra.
And then
All right, let's get E. So we go to equation 3, right? Equation 3. And when we go to equation 3, we've got 3 times A, which was 24. Let me make sure I get this right. Minus 3 times B, which was 8. Plus C, which was negative 24. So I'll make that minus 24. Minus D, so minus 17, plus E equals 0. And here we go again. So 72 this time, minus 24. Has someone done this yet? Anyone have it yet?
I believe it's -7.
Let's see,
Yeah.
-7. We got a couple of people say that.
7.
Negative or positive?
Negative.
-7? Okay. Is it? Yeah, okay. I mean, I'll trust you if y'all say it's -7, I'll trust you. We'll check it in a second. All right, we made it. Now we need to write the answer. So remember, what we were doing was partial fraction decomposition on this, and we said it was going to turn out to be this, right? So it's very important that you put your numbers in the right place now. So I'm going to write this up here. So I'm taking this right here, and I'm going to write it down right up here. So A was 24, so we should have 24 over X plus B. B was 8, so 8 over X squared. Plus C was negative 24 over X minus 1. And then plus D, which was 17, so 17 over X minus 1 squared. And then plus E, which was -7, we think, over X minus 1 cubed. There is the partial fraction decomposition of that rational function. Now, I promise you that on your exams, okay, or on your exam that covers this, I promise you that A, B, and C, like these numbers that you get, are going to be nice whole numbers. So if you start getting fractions, something's wrong, right? In Cal 2, you're going to get fractions, okay? It happens. But here I'm going to keep it where that'll keep you kind of confident that you're going in the right direction. If all your numbers are turning out to be nice whole numbers, then you can feel good that you're doing it the right way, okay?
I have a question that's slightly off topic.
Yeah.
Are we allowed to use calculators on the exam?
You can, but you cannot use a calculator that can do this, because there are calculators that can do this.
So like a scientific calculator?
That would be a calculator that has a computer algebra system on it.
Mm-hmm.
So the TI 89, the TI 92, the TI Inspire CAS. It has to say CAS on it. If it doesn't say CAS, you can use it. But you are allowed to use calculators, absolutely.
Okay.
I don't even think I could do it on a calculator. So
what's that?
I said I don't even think I could do it on a calculator if I wanted to. So
yeah. So I have. Let me see how good this comes out. I don't know if that comes out very good. Okay. So, yeah, I don't know if that's going to come out good, but let me see here. Well, let me do this.
Okay.
TI 84 is fine. Just can't be an 89, 92, or the Inspire CAS.
Yeah, I have a TI 84 as well.
Yeah, that's fine.
So if we were to use the TI 84 on the exams, do you want us to show you the calculator?
No. No, what I would be worried about is if you did the problem like this and you just had the answer written down, no work, right? And then obviously nobody in here, including myself, can get that answer without doing work. So I'm going to, let me do this problem. I'm going to type it in. I'm going to go to Wolfram Alpha, which you may or may not be familiar with. I'm going to type in the problem we just did. It was x cubed minus 8 over x squared, x minus 1 cubed, over, divided by, in parentheses, x squared times x minus 1 cubed. Okay, that took me about, I don't know, 20 seconds to type in. So I'm going to type in, I'm just going to hit enter and see what this thing does. So it's going to do a bunch of stuff. It's going to graph it for me. It's going to do all this stuff. Oh my goodness, look at this line right here. The partial fraction decomposition. I mean, he just did it for me, right? That's like insanely disgusting, right? That you could just like spit that out so fast for us. But is that our answer? They have it in kind of a different order here, but do we have 20? A was 24, right? B was 8. C was negative 24. D was 17 and E was negative 7, right? So there it is. So you might be asking yourself, like, well, if the computer can do it, then why are we doing it, right? Like, why are we having to do this? And that's a great question, you know, like, why go through all of this if computers can do it? Well, there's a couple of answers to that. One is, you know, it depends on what you're doing. Like, if you're an engineer building a bridge, like, you're going to use the calculator to do most of your mathematical computations. And that's because the computer's not going to make the mistakes you're going to make, right? It's not going to make those little errors, signs, and forgetting the x squared or something, right? So definitely you're going to want that. But you still have to learn the process. You still have to learn the procedure. Somebody has to program the computer, right? Like, somebody programmed the computer to do this. And so whoever programmed this needed to understand the mathematical, like, theory behind it. So if all we ever learn is just how to use a computer to get an answer, you get to this point where it's dangerous, okay? When I was in graduate school, I took a class called numerical analysis. And so we had a project due at the end of the semester. And the project was that we had to go find 3 different math programs and feed the math program a problem where the math program would give us a false answer. And so the danger is this thing that my professors talked to me about, the black box, okay? So if nobody knows how to do it, right? If we've just come so far that we're depending on computers for everything, we have this idea that you have the problem, right? Whatever you're working on, building a bridge, building an airplane, you feed it into the computer, the black box, right? Nobody knows what's really going on. And then you get this answer. And the question is, can you trust this answer or not, right? Can you trust the answer? So the class I took, our task was to give the computer a problem that would give us an answer that we knew was wrong. So we actually had to look at the way that the computer was coded and find a weakness in the code and exploit it. Does that make sense? So when you're learning this stuff and then you see a computer do it like that, it's very discouraging. But there's a bigger picture here. Like, we still have to maintain some level of understanding. And that means you have to still know how to do this, right? So maybe we get to a point where we wean it off. But for now, for you in this class, this semester, 2021, you have to do it. Okay, so was that fun or not? That was almost an hour. Okay, we are going to move on to the next example. So this example's new. This is different, all right? The first step is that we are going to, let me bring these steps here. The first step, as usual, is that we're going to inspect the degree of the numerator and denominator. And here the degree of the numerator is 1, degree of denominator is 3, so we can move on to step 2. All right, so now we have to factor the bottom. So can anyone tell me whether or not this factors x cubed minus 1? Anybody recognize that x cubed minus 1? What if it was x squared minus 1? What if it's not, but what if it was x squared minus 1? Do you all recognize that? Difference of squares?
Mm-hmm.
X squared minus 1 is a difference of squares.
So
Okay.
this would be the difference of cubes?
This would be the difference of cubes. And there is a formula for it. And in college algebra, I'm sure you saw it, but you may not remember it. And you don't need to memorize it because it's on your formula sheets, but you need to know it's there. Uh-oh, where are your formula sheets? Did I not put them in here? Okay, so the formula sheets are in your, I put them here on the website for us. Let me see.
Yeah, they're
I'm
on the Canvas homepage.
What is that?
They're on the Canvas homepage.
Yeah, but I don't see I don't see difference of cubes formula here. Interesting. I'll look, you know, I have a different sheet. I'll post this for everyone. I'll post this later on today. I have a different set of formulas that I'm going to give you that I would prefer you start working with these instead of the ones that came out of the book. Let me just show them to you real quick. This is the set of formulas that I allow all my calculus students to use, and it's based on the calculus book. And so you can, I'll give these to you and you can use these on your test. The sooner you start working with these, the better off you'll be, because you'll need these in calculus, all right? So if you look at this, the first sheet here, let me see if I can zoom in on this. We have the special factoring formulas right here. And here we have the difference of cubes formula. I'll just do a quick little copy of this and we'll bring it over to the notes. Now you still need to know that this is a difference of cubes, okay? You still need to recognize that it is, but then you can just use this formula. Okay, I know that's kind of blurry, but it's saying that if we have something cubed minus something else cubed, it factors to be this. All right. So for us here, we have an x being cubed and a 1 being cubed and then subtracted. So this should turn into, let's see, x minus 1 and then x squared plus x plus 1. So just keep in mind here, the x here is x and the y is actually the 1. So all I'm doing is rewriting this formula, replacing all the x's with x and all the y's with 1s. Now there's something important that you need to know about this formula, this difference of cubes formula. Does everyone see that when you use a difference of cubes formula, that this right here in yellow gives you a quadratic? Y'all see that? That quadratic will never factor, ever. Okay, so it's not factorable. If it was factorable, then the formula would factor it for you. Like the formula would include a factor, but it does not factor. So this right here is what we call irreducible. This in yellow is irreducible. And that's what this example is about. What happens if you have an irreducible quadratic factor? What do we do? All right. So let me write down where we are, and then I'll take questions if you have any. We're going to write down the original numerator, and then we're going to write down the factored form of the denominator. And that is completely factored. There's nothing else we can do to factor this quadratic. Are we okay with that?
Yes.
Okay.
Yes.
So this here is linear. We all agree that's a linear factor. And this is an irreducible. So the way they refer to it is an irreducible quadratic factor. So what do you do? I haven't shown you this, right? What do you do when you have this? Okay, well, we know what we do with the linear factor. We put a over the linear factor, right? Does that follow what we've been doing? We have a linear factor, we put a letter over it, boom, we're done. If that had been x minus 1 squared, we would have done a over it and then plus b over that thing squared. But it's just x minus 1. Now, here's the big change. If we have an irreducible quadratic factor, here's what we put. We put the irreducible quadratic factor. We put it on the bottom, okay? Here's the change. On the top does not go just a letter, like b. You have to put bx plus c. Now, I know that that's weird, but just look at what it is. Do you all agree that the a over here is just a number, right? It's just a number. And on the bottom, it's linear. So if you think about like degrees of polynomials, we would say that the bottom, this degree here is 1. Do y'all agree the degree of that's 1? And the degree of the polynomial on top, there's really like an x to the 0 here. So we could say the degree on top is 0. So the degree of the bottom one is 1 greater than the degree of the top. Follow me now. Here on this other one, if it's an irreducible quadratic, the degree of the bottom is 2. What's the degree of the top?
1.
1. So you're always going to be wanting to put the thing that's on top is always 1 degree less than what's on the bottom. I know it's a little confusing, but it's, you know, it's our first look at it, so give it some time. All right, so we have our A over our linear. We have a linear expression over our irreducible quadratic. Bx plus c is linear. And now we just play the same game. Okay, we just do what we've been doing. We're going to multiply both sides by the LCD. Any questions? Do that here. Multiply both sides here by this. Oh gosh, that's messy. We have to distribute and then they'll kill all. All right, so there's only one person I have not called on, I believe, and that's Anna Marie.
Yes.
Anna Marie, can you tell me on the left side what's going to happen when I multiply all this together? What am I left with?
The bottom's going to cancel and you're just left with 3x minus 5.
Yep, that's it, 3x minus 5. Good. You want to keep going? You want to tell me what would happen for this first one when I multiply on the right side, just that first one, what I'm left with?
You're left with a multiplied by x squared plus x plus 1.
That's right. So the x minus 1's cancel. You seem like you understand this. That's good. Let's see. Let me move on. Oh, you know what? Tyler. I don't think I got to Tyler last time. Is Tyler here?
Yeah.
Hey, how's it going?
Hi.
Oh, you were having problems with your phone or something, right? Last time?
No, just in general, my computer wasn't working, so I wasn't able to like log on last time, so I missed that first class. But
Well,
I'm understanding.
forget about you.
Yeah.
Okay, so are you following this, Tyler?
Yes.
Okay, so what would happen on this second distribution through here? What would we do?
The x squared plus x plus 1 cancels.
Okay.
So it would be the x minus 1 times bx plus c.
Exactly. So you still have the bx plus c, right? But you have to multiply that times the x minus 1 that's still there. Now be careful, everyone, right here. Be very careful with this. This bx plus c is in parentheses, okay? Because you're going to be multiplying this bx plus c by whatever's left here. So you have to hit that with the x minus 1, which means you're going to have to do a FOIL here. If you do not put the parentheses, this is a mistake, because then you'll just distribute the c through, and that's not right. It's got to be the whole thing. That's a common mistake. Okay, so that's why I want to make sure I point it out. All right, now the shortcut here would be to try and figure out what A is, or figure out what B is, or figure out what C is. It's not going to work. And the reason it's not going to work is because there's nothing you can do to ever make this 0. This right here, because it's irreducible, means it can't factor. It means there's no x we can plug in to make this 0. So we're just going to be stuck with the long way. All right. And I would just expect that if you have an irreducible quadratic factor, just expect that you're going to be doing the long way. Okay, here it comes. Distribute. A is going to go through. The distribution on this one's not so bad because it's just distribute and then FOIL. So we should get 3x minus 5, ax squared plus ax plus a. And on this next one, bx squared minus bx plus cx minus c. Okay, at this point, what I'd like to do, it's 10:04. I'd like to give you, let's see. Let me give you 5 minutes to see if you can come up with the system of equations. All right? So that means you just collect like terms together, match your coefficients, and then come up with the system of equations. And I'll call on like 3 people and let one of them volunteer. All right? So This is where I play Jeopardy music in the background. I'm not going to do that, but just imagine that there's Jeopardy music in the background. 5 minutes. Of course, if you finish, just go ahead and figure out what A, B, and C are. Go, you know, if you get the system of equation set up, just go ahead and finish it off. Okay. Let's see, who am I going to call on? Let's go with James, So Young, and Michael Clark. Any of you three want to volunteer your system of equations?
it's just equations, right?
Yep.
So first one, I got a plus b equal to 0.
Okay.
The second one is a minus b plus c equal to 3.
Okay.
And third one, I got a minus c equal to minus 5.
Okay. Does anybody disagree? So we're all okay. I see everyone shaking their head no.
I got the second one wrong, but I see what I did wrong.
Okay. Okay.
The third one, I got negative c equals negative 5.
Negative c. So I think what you may have missed is this a right here,
Oh, yes.
right?
Yeah.
Because it doesn't have an x on it.
Mhm.
Okay. So now, in terms of solving this system, does anybody want to volunteer how they went about solving it? Because this one, you cannot just, like, we just don't know what A is now, right? Or we don't know what B is or C. We actually have to do something. So can someone tell me how they went about it?
I used the substitution method.
Okay.
So I used the third equation and solved for A.
Okay, so you recognize that you could take your third equation, which is A minus C equals negative 5. You solved it for A, so you added C to both sides?
Yes, sir.
So did you put negative 5 plus C or C minus 5?
Negative 5 plus C.
Okay, and then what did you do with that?
Then I put that whole equation in for A in the first one and solved
So
for
you did
B.
the first equation and you wrote A plus B equals 0, and you replaced A with minus 5 plus C, is that right?
Yes, but I'm not
Okay.
sure if that's gonna work now.
Yeah, I'm not sure you're gonna, but okay. Maybe, let's see, let's just stick with it. Okay, so negative 5 plus C plus B equals 0. So does everyone see all that's happening here is A is this, and then we're taking that A and replacing it with that right there. Yes? All right, so I know you're hesitant right now because you're not sure if this is going to work, but check this out. Look at your second equation. Your second equation has A, B, and C in it, right? It would be nice if all it had was A's, or all it had was B's, or all it had was C's. But you know that you can replace A with something that has C in it, right? And if you solve this equation that you just set up, if you solve that for B, what would we get? If we solve for B, we are just going to get 5 minus C, aren't we? If we just take this B and move the C over and move the 5 over, we get this?
Yes, sir.
And so that means your B can be replaced with things with C's. So let's do that. Let's take the second equation, which is A, take away B, add C equals 3. Let's replace A with what? And Anne-Marie, you're off the hook here. You don't have to keep answering. This is for the whole class.
Negative 5 plus C.
Negative 5 plus C. We can replace the B with, so be careful. We're going to go minus, that's that minus sign right there. B, but B is 5 take away C, that's this. And then we still have plus C equals 3. And does everyone see that now that equation just has C in it? So we should be able to solve this for C. Very important that you see that that minus sign stays and that the B here has to be in parentheses because that minus has to distribute. So we get negative 5 plus C minus 5 plus C equals 3. So that's just me distributing that minus through. And now just collect like terms. Let's see, we get negative 10 plus 3C equals 3. And then if I go 3C equals, let me add 10 to both sides, I get 13. So C is 13 divided by 3. Okay, so I didn't check this. Did everyone agree on the system of equations, right? I'm not sure if we're gonna get an answer that's a fraction here. Let me check with I got this problem from the book, so let me just double check that that this is actually right before we continue. Okay, it's this one. Okay, yep, that's right. All right, so we got a fraction. Okay, so but remember on the test, I'm going to promise you that these are going to be whole numbers. I'm going to make sure the problems are whole numbers. All right, so we know what C is. Once we know what C is, it'll be easy for us to go back and get A and B because we have equations for them, don't we? Here's the equation for A, here's the equation for B. So to get A, I'll do it on the side here. A is -5 plus C, but C is 13 over 3. And to do that, we have to get a common denominator. So we have to look at that 5 as being 5 over 1, multiply the top and bottom by 3. So we get -15 over 3 plus 13 over 3, which equals -2/3. That's what A is. And then B is 5 take away C, so take away 13/3. Same thing, get a common denominator. Any questions? 2/3.
Yes, sir. So why are we doing this again? Once we have C as a fraction, are we just double checking our work?
No, because we have C, but we don't know what A and B are.
Oh, okay. And we're using C to help us find A and B.
That's right.
Okay.
And we're using these equations because these equations already have A and B solved for, right? A is -5 plus C and B is 5 minus C. So we just use these because we know what C is.
Oh, okay. Thank you.
Mm-hmm. All right. So we're there. We're there. We just need to write our answer. So I'm going to come back up here. And I think I'm going to slap it in. We're going to be taking this right here, replacing A with -2/3, B with +2/3, and C with 13/3. All right, it's going to look weird. Watch me write this. Okay, A is 2/3. So watch the way I write this. 2/3 over x minus 1 plus B is -2/3. -2/3 x plus C, which is 13/3, all over x squared plus x plus 1. I know that that looks weird, but trust me, in calculus, that's the way we're going to write it. So that's the way I'm going to write it here. So that's the A, the B, and the C being replaced with the 3 answers we got. Any questions?
I have a quick question.
Yes.
On the homework, will it want us to put the fractions as decimals in our answer when we're writing it in?
No, it's
Or
going to
will it
want you to
accept
leave them.
fractions?
It's going to want you to leave them as a fraction because 2/3.
Okay.
If you convert 2/3 to a decimal, it's 0.666 repeated, and so they want exact answers, and exact answers is just leaving the fraction as is. Now, would it take the answer?
Thank
It
you, sir.
probably would accept it. The computer would probably accept your answer as a decimal. But all of you, most of you need calculus, and we just don't ever really use decimals in calculus. It's always left as fractions. Always, most of the time, 99%.
I know that my math lab can sometimes be tricky the way it accepts answers.
Yeah, so it usually tells you, if it tells you to round or approximate, then they want the decimal. If they don't say that, then that means they want the fraction.
Okay. Thank you.
All right, you're welcome. All right, well, I think we have one more. Yeah, we have one more to do. And we have 20 minutes. So let's see how we do with this. All right, so degree of the numerator is 3. What would the degree of the denominator be?
4.
4, because it's x squared plus 4, but then we're squaring it, so that would give us a 4th power. So we can move on to step 2. So I'm going to factor the bottom, but it's already factored. How do I know it's factored? I know it's factored because x squared plus 4. There is not a formula to break down x squared plus 4. Had this been x squared minus 4, then we could factor. Difference of squares, there's a formula for. Sum of squares, there is no formula. It does not factor. So what we have here is an irreducible quadratic factor. Do you all agree? X squared plus 4 is irreducible. It's
Yes.
quadratic, but the fact that it's squared means it's repeated. So watch what I do. I think after I do it, you'll hopefully catch on to this. I'm going to write down the irreducible quadratic with a linear expression on top, ax plus b. But because it's repeated, I have to do plus, and now I have to do the irreducible quadratic again, this time squared, with cx plus d, another linear expression on top. So remember how, like, if the thing down here was like x cubed, we would do x, then x squared, then x cubed, and we'd build it up. We're doing the same thing here. We have an irreducible quadratic that's squared, repeated, and so we have to build it up. X squared plus 4, then x squared plus 4 squared, and we stop there. Any questions on that?
So we're just breaking it down. So like, so we're building up the original equation.
We're building up this to the power that we see here. If this had been a 3, we would need another one.
Oh, okay.
Right, if this had been a 3. So if it had been a 3, I'm going to erase this. If it had been a 3, we would now do x squared plus 4 to the 3rd. And up here, we would have like ex plus f or something like that. So there's a couple of things that you have to be aware of here. We're building up the denominator, but the numerators are not just a and b, right? It's ax plus b, cx plus d, because anytime you have an irreducible quadratic on the bottom, you have to put a linear expression on top, not just a letter. All right, and now we come in and multiply both sides. So I'm going to work through this one. Okay, I'm just going to go kind of quick here. X squared plus 4 squared, I'm going to do that on both sides. Cancels out here. I get x cubed plus x squared. And on the right, when I multiply this thing through, one of the x squared plus 4s goes away, but I still have one of them. So it's going to become ax plus b, that's the numerator, times one of those x squared plus 4s. And then when I do the second multiplication, both the x squared plus 4s goes away. So all I'm left with is the cx plus d. Then I FOIL here. Okay, ax cubed plus 4ax plus bx squared plus 4b plus cx. I know I'm moving fast, but I hope that you have caught on to the idea here. Okay, I only have one x cubed, so I'm going to put that there. X squared, I only have one. X's, I've got a few of them, so let's see. I've got 4a here, plus c, and then an x, that takes care of those two. Then I have a 4b plus a d by itself. And now we get to play our game of matching the coefficients. So let's go with Caroline.
Yes.
Okay, so what's the first equation that I'm going to set up here? Working with the ax cubed.
I think it would
What does
just
a
be
have to be?
a equals 1.
Okay, a equals 1, right? Because it has to match the number on the x cubed over here. So I'm going to put a equals 1. You want to keep going?
Yeah.
All right, what do you have next?
B equals 1.
B equals 1. And that's matching this one with the 1 there. So B is 1. You want to keep going?
Yes, and I think it would be 4a plus c equals 0.
Yep, 4a plus c has to be 0 because there is no x term on the left. And we may as well just finish it off.
4b plus d equals 0.
Yep, 4b plus d must be 0. And that's because there's, where's my cursor? There it is. Okay, so this is like a number, right? Whatever it is, it has to match with the number over here with no x's, so it has to be 0. Any questions on that? We know a is 1. We know b is 1. That's nice. Using the third equation, we can figure out that, let's see, 4 times a, we know a is 1, plus c must be 0. So Lauren, what's c?
I was just doing it. It is 5
C
or
is,
negative 5.
that's 4 times 1.
Do
Right?
what?
This right here is 4 times 1, not 4 plus 1.
What, 4?
So that's 4 plus c is 0. Right?
And negative 4.
Negative 4. Okay, so c is negative 4. Good. We're almost there. We just need d. So equation 4, let's see. Genesis, what do you have for that one?
It would also be negative 4.
Yep, d is negative 4. There we go. So just using the equations, using the fact that we know what a and b are, we just replace this b with 1, that a with 1, solve for c and d respectively, and we've got a, b, and c, a, b, c, and d. So 1, 1, negative 4, negative 4. So now I come back over here and I'm ready to rewrite this with a, b, c, and d replaced. So this should be equal to, let's see, a was 1, so x plus b was 1 over x squared plus 4. And then plus, now c was negative 4 and d was negative 4 over the x squared plus 4, but this time squared. And there's your partial fraction decomposition. All right, what do y'all think? Just gonna have to be careful, right? You're just gonna have to be real careful, meticulous, take your time. What's that, James?
Oh, yes, sir. I felt that this problem was a lot easier than the last one.
I agree.
I
agree.
I felt that like after we found out what like A, B, C, and D equal to, I felt like it just connected right there.
Yeah, this one was the hardest one we've done, right? This one, that was the hardest one because there was just so much that we had to keep track of. Okay, so what I'd like to do now is I'd like to pull a problem from my Cal 2 class, all right? Because I've still got 12 minutes. So give me a moment, I'm gonna open up a file. We're just gonna pull a problem out of my Cal 2 and we're gonna do partial fraction decomposition on it. Oh, where is it? I thought I had this open, but I think my computer did a restart. So give me a moment to find this. No, that's not it. Oh yeah, we can do that. It's coming, hold on. Trying to pick which one I want. That's a good one. All right, here we go. So we are going to do partial fraction decomposition on this, all right? First thing is to compare the degree of the numerator and denominator, right? That's the first thing we do. Where are my steps? Here we go. So we're going to compare degree of numerator and denominator. If the degree of the numerator is smaller, then we go to step 2. Any other case, we don't do step 2. We have to do long division. So do y'all see that these degrees are the same?
Yes, sir.
So we have to do long division first. And this is the first time we've had to do this. So long division is something that always bothers people. I don't know. It's just something about it. All you're going to do is just like you did. Look, if you take 15 and divide it by 4, right? Good old grade school math. You put the 15 inside, put 4 out here, and then you just ask yourself, like, what do I multiply 4 by to get 15 without going over? So 4 is too big. 4 times 4 is 16. So you have to go 4 times 3. And then you multiply 4 times 3 is 12. You put it here. And then what do? Subtract, right? You subtract this row and you go, your remainder is 3, right? And so back in the good old days when you're like still barely learning to write, you would put 3 remainder 3, right? And then later on, hopefully you learn that, no, that's not the way we write it. We put 3 and then 3 our remainder over our divisor 4, 3 3/4. That's what hopefully you learned after remainder. And then this you didn't stress as much in grade school, but what does 3 3/4 really mean? It means 3 plus 3/4. That's what that means. When you write 3 3/4, you're saying 3 and then add 3/4 to it. Okay, so that's just a real quick like reminder of the way long division works. We're going to do that with polynomials. So we're going to write a division box. In the inside of that goes the numerator, not the denominator. Numerator goes in here. And on the outside goes the denominator. All right. Now, just like we did in the problem below, when we were looking at 15 and saying, okay, what do I multiply 4 by to get 15? We're going to do the same thing here, but we're only going to look at the leading terms. So what would you multiply 4x squared by to get 4x squared?
1.
1. So we put a 1 up here, and it really doesn't matter where you put it. I'm going to put it here. And then what you do is you multiply that 1, just like we did when we put a 3 here. We multiplied 3 times 4 and put our 12 here. We're going to do the same thing. We're going to take 1 and we're going to multiply this entire polynomial by 1. So it multiplies each of those 3 pieces. So when you multiply the 1 times this one, you get 4x squared. We put it here. When you multiply 1 times that one, you get minus 4x. And when you multiply 1 by that one, you get 3. Are there any questions? Now, just like we did down on the bottom, once you get that 12 there, you subtract the 12, don't you? Well, here we have to subtract this. So we actually have to take this entire row and subtract it, which makes everything that was positive becomes negative. I'm sorry, everything that was, positive becomes negative. Everything that's negative becomes positive. Right, so all these things change signs. And then you add down. So when you add these first 2 down, they go away, you get 0. When you take negative 3x and add 4x, that leaves you with just plus x. And when you take 2 and take away 3, you get minus 1. Any questions? All right, I'm gonna get rid of that stuff there and move it down. Get it out of our way. Okay, so now you play the same game. You ask yourself, what do I multiply 4x squared by to get, well, let me clean this up. I don't need the 0, I don't need the plus. So what do I multiply 4x squared by to get x? Well, you can't, because 4x squared has a bigger power than x. So this is your remainder. X minus 1 is your remainder. So the way we write this is we write plus the remainder over the divisor.
Wait, real quick.
Yep.
Why couldn't you just say that you'd multiply 4x by x to get 4x squared?
Because you're trying to figure out what you multiply 4x squared by to get x, not what you multiply x by to get 4x squared. I'm not sure if I understood your question.
Well, you said we would just put the x minus 1 up as a remainder with the equation underneath, because I'm just trying to figure out why we couldn't put 1 plus 4x instead.
1 plus 4x.
Because 4x times x would be the 4x squared.
I'm not sure I'm following you. Okay, do we agree that this is what happens when you add these down? We get x minus 1?
Yes.
Okay, so do you understand that you cannot multiply 4x squared by anything to get x?
Okay. Yes, I agree.
Right? So what would I multiply this by to get x? If this were x cubed, then I could do something, but the problem is this power on this x is smaller than the x squared, so you can't multiply by anything. Does that
Okay,
help?
so 4x squared can't go down to an x.
Can't come down to x, exactly.
Got it.
So that's where we stop. So it's kind of like on this step, when we had a 3 here, you couldn't multiply 4 by anything to get 3 because 3 is smaller than it, right? So that's why here, x is, the power on x here is smaller than 4x squared, so I can't do anything.
Okay.
Okay, so that becomes my remainder. But instead of writing 1, remainder x minus 1, we don't do that. We really write 1 with x minus 1 over the divisor. But this really means 1 plus that remainder over the divisor.
Okay, got it. Thank you.
Okay. Is everyone okay with that or not?
Yes, sir.
Okay, so now let's see where we are. Okay, so here's where we are. This expression really becomes that numerator up there, 1 plus x minus 1 over 4x squared minus 4x plus 3. Okay, we have done the first step. The first step was long division, and we've completed the long division, and here's what we have. Now, looking at this, does everyone see that this here is a rational function where the degree of the numerator is now smaller than the degree of the denominator?
Yes.
Yeah, so now we can do partial fraction decomposition on just this green part.
So that's what we were trying to do right there. We were trying to make the numerator 1 less than the denominator.
That's right. That's exactly what we were trying to do. The long division is the only way we can make that happen. So we need that step. So now we're just going to continue now with what we did before. Just don't forget that our answer has a 1 in the very front. People always forget about this 1. Okay, this 1 is going to be in our answer, but right now I'm just going to focus on this. And when I do this now, I'm on step 2 now. I'm going to factor the bottom. Or you know what? I'm not going to factor the bottom. I'm not going to do anything. So here's your first opportunity to gain bonus in this class. I want you to finish this problem out, okay? And what I'd like for you to do is this. Do it on your own sheet of paper. Start from scratch. Not from scratch, but start from this point here, okay? Just write that down on a separate piece of paper. Put your name on that piece of paper, and I want you to work through the rest of it. Okay, do the partial fraction decomposition, get your final answer. Now, when you're done with that, I'd like for you to take that work that you have, okay? If it's just 1 page, I want you to put like a cover page on it, like with your name or something. I want you to submit to me through a Dropbox link that I'm going to send you in just a second through your email. There's going to be a link, okay? You click on it, it's going to let you upload the file. I want you to upload two pages to me, okay? 2 pages where you take pictures with your phone of your pages and you convert those into a PDF. I know I'm throwing a lot of information at you right now, but this is an opportunity for us to practice you sending me multiple pages as PDFs. The key though is that it has to be a single file. So you might have to use an app like Cam Scanner or something like that. So you take your pictures and you convert those pictures into a single PDF file. And I want you to upload that to me. That's a bonus. That's for bonus in the class. All right. You have to finish the problem, but then it's an opportunity to practice this.
So both pictures are in one PDF file?
Yep. So both pictures should be saved into a single PDF file. Now, I'm not going to make this due right away. I'm going to give you a week. just because it's not about you doing this and getting to me right away. It's about you figuring out how to do this. All right, like how to actually turn 2 pictures into a single PDF file. And just look it up, just Google it. You know, how do I turn my pictures on my phone into a single PDF file? And I'm sure you're all intelligent. You can figure out how to do it. All right. And we'll just make this due a week from today before class. Other than that, you have your homework assignment through My Labs. And that homework assignment, if we look at it now, I don't know if I still have it up here. Yeah, there's what, 15 questions here. So see how this goes. And I did not talk to you all about this because I figured it would be easy for me to explain. The first questions are asking about whether or not an expression is proper or improper. Proper just means that the degree of the numerator is smaller than the denominator. Okay, so if you don't need long division, it's proper. If you do need long division, it's improper. It's a very simple concept once you understand it. So if you don't need it, proper, do need it, improper.
And then we check that by the numerator's 1 less than the denominator.
Well, just less. It just has to be less. So here 2 is less than 3, right? So this is true. It's proper. Okay.
Okay.
And yeah, so let's see how it goes. Like I told you last time, my plan is to work through these problems in my office hours, you know, so I will post video solutions to these problems, hopefully within the next day or 2. It's due tomorrow at midnight, so hopefully I'll have the video done by the time it's due so that you can go and kind of see if you're stuck on something. Are there any questions?
What's due tomorrow at midnight?
This homework for 12.5, partial fraction decomposition. So you have to go onto the My Labs website, get enrolled. Let me see if I can see how many students are enrolled. I'll have to, no, I don't want to look at that. But you should have already done this. If you haven't, it's pretty simple to get in here. Would you all agree, those who have done it, it's pretty easy to get enrolled in this?
Yeah,
And then you're just going to click on your homework assignment. It'll look like, this is what it's going to look like to you. You just click on this first homework assignment. It's due 11:59 of January 26th. And you're just going to click on the question and put in your answers.
And if you're already enrolled, like from a different math class, it will just pop up under your account that you already have.
Oh, if you already have an account? Is that what you're saying?
Yeah. It will just automatically be there.
Yeah, good. I do not want you all to get stressed out about, hey, the computer is counting it wrong, but I'm, you know, I feel like I'm doing it right. And I don't, this is all about the procedure and the process. Are you getting that right? You know, I'm not, the homework grades are not that important to me. You know, if you're getting hundreds on your test, but your homework problem, your homework scores are low because the computer's, you know, taking it, don't worry about it. I will not let your homework damage your grade if you're doing well on exams. It's just a place for you to practice and get feedback and be able to know if you're getting it right or wrong. And it is the best we can do at this point, right, with technology and stuff. So, all right, you're free to go. I'll hang out if you have any questions.
I have one question. Whenever you do, so like, can we check our answers with that video that you create and make sure that we're doing our work right?
Yes and no, because your problems might be a little different than mine. So they might change, like mine might have like 5x squared minus 1 and yours might have like 8x squared minus 1. So there might be little differences in our numbers. It's more about checking. You can check to see if we're doing things the same way.
Okay.
Right. And if you get lucky,
It's the same concept.
Yeah, it's more of the concept.
Okay.
Got it. Okay.
I had a quick question on the downloading of the PDF.
Yes.
So I use an app called GoodNotes, and that's how I do my homework. And it's able to compress like all my pages that I use into a PDF and send it in through the Canvas app.
Yeah.
Is that okay?
That's okay. It's the only difference is that I'm gonna have you submit it to a Dropbox. So it's
Okay.
not a Canvas, it's not within Canvas, it's gonna be just a separate link that you click on. So as
Okay.
long as you have that file like somewhere stored on your phone or computer, you can just upload that file.
Okay.
Any other questions?
You can also use a scanner too, right? To like,
Like,
use
yeah,
it
like,
on the USB.
like a traditional scanner, like just
Yeah.
do it that way, yeah. Mm-hmm.
Thank you.
You're welcome. Is that it? Okay, good luck on your homework, everyone. Thank you for your participation. I will see you on Wednesday.
Have a good day.
Too.
Thank you. Bye, sir. Thank you.
Bye.
Thank you.